In this module, I'll be explaining comparators. What are comparators? How can a comparators can be made using operation amplifier? Comparator is a circuit which compares signal voltage applied to one input of operational amplifier with a non-reference voltage at the other input voltage. For an op-amp in which there are two terminals, one we call it as non-inverting terminal, second terminal is called as inverting terminal. To the one input of either non-inverting or inverting, you will be applying the signal to be compared, and to the other input you will be connecting the reference voltage. Either can be ground voltage or it can be positive voltage or negative voltage. For in this circuit, it is just shown as we are applying a reference voltage, ground voltage as such. And here you can see that one, then this is the output voltage. Once this voltage at the non-inverting terminal is coming more than the inverting terminal, you will be getting this plus Vsat. And when during the negative half cycle, when the voltage at the non-inverting terminal is coming less than the voltage at the inverting terminal, you will be getting minus Vsat. So that this input voltage that is applied to the non-inverting terminal is being compared with the voltage that is applied to the inverting terminal in this case. Therefore, he will be getting a sinusoidal signal that will be converting into a square waveform, and that's actually zero crossing detector, and we'll be seeing the later. Anyway, comparator compares the voltage at a particular input, either inverting input or non-inverting input, and with the other terminal of the other terminal voltage. And then based on the magnitude of this one, you will be getting either plus Vsat or minus Vsat. Therefore, it is basically an open loop op-amp. Therefore, there is no feedback as such, open loop op-amp, and the output voltage can be either plus Vsat or minus Vsat. That is, this is a comparator circuit of, this is actually zero crossing detector in which comparator is using as a zero crossing detector in which one input is the ground voltage. Now, the comparators can be classified into two types. One we call it as non-inverting comparator. Second we call it as inverting comparator. Therefore, if you are giving the input to the non-inverting terminal, we call it as non-inverting comparator. Instead of that one, if you are giving the input to this inverting terminal, it is called inverting comparator. Let us consider a non-inverting comparator with positive reference voltage. A non-inverting comparator in which you are giving the input to the non-inverting terminal. This is the signal that is compared with what? That is, in this case, we are considering a positive reference voltage. Therefore, that reference voltage is given here to the inverting terminal, and here, since we are comparing with a positive reference voltage, you are applying a positive voltage at this point. So this is the positive reference voltage, and this is the input voltage, and this input voltage is compared with the positive reference voltage, and the theory or the thumb rule behind this one can be written as this one. If the input voltage for a non-inverting comparator, if input voltage is more than the reference voltage, output is equal to plus Vsat. V0 equal to plus Vsat. Now, if input voltage is less than V reference voltage, output voltage equal to minus Vsat. If input voltage is less than V reference, output voltage equal to minus Vsat. You can apply this, you can remember this as a thumb rule in this case of a non-inverting comparator. Now you can apply this one to this waveform. Therefore, this is the input waveform. It's a sinusoidal input waveform and this applied to a non-inverting terminal, and that is compared with a positive reference voltage. This is the positive reference voltage. Assume that this is equal to say 10 sin omega t, and this reference voltage equal to 4 volts, something like that. This is the reference voltage. It's a positive reference voltage. Now apply this. If input voltage is more than reference voltage, output voltage equal to plus Vsat. Therefore, in this case, if you see that one from here to here, you can see that input voltage is more than the reference voltage. That is why during this period you will be getting plus Vsat. Now, if you come to the before this one, you can say that one input voltage is less than V reference voltage. If input voltage is less than V reference voltage, output voltage equal to minus Vsat. That is why we are getting a minus Vsat. That is changing plus to Vsat. Again, if you see here, from here to here, the input voltage is less than the reference voltage. If input voltage is less than reference voltage, output voltage equal to minus V sat. That is why here the output voltage you are getting from the during this one equal to minus V sat. Then that will be continuing. Therefore, this is the rule that is following in order to get the output voltage based on the magnitude of input voltage and the reference voltage. Therefore, this is a non-inverting comparator because we are giving the input to the non-inverting terminal and the reference signal is given to the inverting terminal. Now continuing the non-inverting comparator, previously we have given a positive reference voltage. Now here we are giving to a negative reference voltage. A negative voltage is given. Therefore, this is the input voltage and the reference voltage is now negative. Therefore, we are giving a negative reference voltage and the same input voltage is given to the non-inverting terminal. And then the rule is same as the previous one. In the case of a non-inverting terminal, if input voltage is more than the reference voltage, output equal to plus V sat. If input voltage is less than V reference, output equal to minus V sat. Therefore, same rule it can be applied to here also. Therefore, if you see this one, the input voltage is more than the reference voltage until this point. That is why you are getting a plus V sat. Now from here to here, you can see that one input voltage is less than the reference voltage. That is why the output is equal to minus V sat. It is equal to minus V sat. Then again from you can see that one input voltage is more than the reference voltage. That is why again that is changing to plus V sat. Therefore, the output will be either plus V sat or minus V sat. That is decided by the magnitude of input voltage and the magnitude of the reference voltage. And the rule behind is this much only. If input voltage is more than the reference voltage, output voltage equal to plus V sat. And if input voltage is less than reference voltage, output voltage equal to minus V sat. This is the rule for a non-inverting comparator. Why for an inverting comparator that we'll be seeing later, it will be just it will be the reverse of this one that will be explaining the next slide. Anyway, for a non-inverting comparator, either you are applying a positive reference voltage or a negative reference voltage, output voltage will be plus V sat if input voltage is more than reference voltage, and output voltage equal to minus V sat if input voltage is equal to less than V reference voltage. So that output voltage will be either plus V sat or minus V sat depending upon the magnitude of the input voltage as well as the reference voltage. Now coming to the second type of comparator, that is called the inverting comparator, in which you are giving the input to the inverting terminal. You are giving the input signal Vi is given to the inverting terminal and the reference signal is given to the non-inverting terminal. Therefore, just it is interchange compared to the previous case. Therefore, in this case, the equation is also changing, just interchange like if input voltage is more than reference voltage, output voltage equal to minus V sat, and input voltage is less than V reference, output voltage equal to plus V sat. It is just opposite to the previous equations for a that is discussed for a non-inverting comparator. For inverting comparator, this is the rule to be followed, and this is the input waveform. And here with a positive reference voltage, we are applying a positive voltage. For the positive reference voltage, it is applied, and you just apply this theorem. That is, if input voltage is more than the reference voltage, that is during this period, output voltage equal to minus V sat. This is a minus V sat will be available here. That is why during this period you will be getting minus V sat. And if input voltage is less than the reference voltage during this period, you can see that output voltage equal to plus V sat. That is why you are getting a plus V sat. Therefore, it is just opposite to the previous case. Therefore, depending upon the input voltage magnitude and the reference voltage, output will be either minus V sat or plus V sat. The rule is that one, if input voltage is more than the reference voltage, then output is equal to minus V sat. And if input voltage is less than V reference, output voltage equal to plus V sat. Therefore, either it will be plus V sat or minus V sat depending upon the relative magnitude of the input voltage as well as the reference voltage. So this is an inverting comparator with a positive reference voltage. You are applying a positive voltage at the non-inverting terminal, and for the inverting terminal you are applying the signal that is to be compared. Again continuing the inverting comparator, previously we have seen a positive reference voltage. Now you are going to see a negative reference voltage. Therefore, we are applying a negative voltage as a reference voltage to the non-inverting terminal. And since it is an inverting comparator, you are giving the signal input to the inverting point. Therefore, this is a signal that is compared with this reference voltage with a negative reference voltage. Therefore, this is the signal that is compared, that is the input voltage. and that is compared with a negative reference voltage, that is V reference. Again, the rule is same. If input voltage is more than reference voltage, output is equal to minus V sat, and if input voltage is less than V reference, output voltage equal to plus V sat. Just apply this theorem for this one. Therefore, if input voltage is more than the reference voltage, means until this one, that is the output voltage equal to minus V sat. It is equal to minus V sat. And if input voltage is less than the reference voltage, output voltage equal to plus V sat. Therefore, here it is equal to plus V sat. Then that will be continuing. Therefore, the output is either minus V sat or plus V sat, depending upon the relative magnitude of the input voltage and the reference voltage. Here in this case, you are applying a negative reference voltage, and the input, if input voltage is more than this reference voltage, output is equal to minus V sat. If input voltage is less than V reference voltage, output equal to plus V sat. Therefore, this is a inverting comparator with a negative reference voltage. Now, in all these comparator, we have seen that one. We are comparing two voltages that are applied to either to the plus terminal and negative terminal, and this is an open circuit. There is no feedback path, and as well as the output will be either the plus of biasing voltage plus V sat or minus V sat, depending upon the relative magnitude of this input voltage as well as the reference voltage. That is the comparator, just like a non-inverting comparator, inverting comparator, and with a positive or negative reference voltages. This is one of the application of a comparator. Is many circuits it is using, that is zero crossing detector. Zero crossing detector. It's a comparator itself. Only thing is that one point is grounded. One terminal is being grounded, and the other terminal you are applying the signal. Therefore, when the one input of the comparator is connected to the ground, it is known as zero crossing detector, or the normally we call it as ZZD, zero crossing detector, because output changes when input crosses the zero voltage. In this case, the output will be changing from minus V sat to plus V sat or plus V sat to minus V sat when the signal input changes the 0 point. So that is why we can detect the point at which the input signal is crossing the 0 point. That is called the zero crossing detector. Based on the input where you are applying, it is again classified into two types. One we call it as non-inverting zero crossing detector, and second we call it as inverting zero crossing detector. In a non-inverting zero crossing detector, it is again a comparator. It's an open, there's no feedback path, and here the input that is given, sinusoidal input, whatever the signal that is given to the non-inverting terminal, plus input, and the inverting terminal is to be grounded. It will be grounded. Therefore, if again you can apply that one, if the reference voltage is more than the if the input voltage is more than the reference voltage, that's zero voltage, then you will be getting plus V sat. If this voltage is less than this ground voltage, you will be getting minus V sat. Therefore, during the positive half cycle, you will be getting plus V sat, and during the negative half cycle of the input, you will be getting minus V sat. So that this sinusoidal waveform will be converted into a square waveform in which the transition from minus V sat to plus V sat, that is taking place at the zero crossing point. Again plus V sat to minus V sat, that is taking place at this point. Therefore, it can detect the point at which the input is crossing the 0 point. That at that point the transition is taking place either from minus V sat to plus V sat or plus V sat to minus V sat. That is why it is called a zero crossing detector. In this case, the input is given to a non-inverting input. Now, instead of giving the input to the non-inverting terminal, you can give the input to the inverting terminal. That is what we call it as inverting zero crossing detector. Therefore, the input is given to the inverting terminal, and again the non-inverting terminal is grounded. Then again, if input voltage is more than the reference voltage, that's a ground voltage, then output equal to minus V sat. And if input voltage is less than the reference voltage, zero voltage, then output equal to plus V sat. That's already seen for a inverting comparator. Same principle that can be applied here. Therefore, during the positive half cycle, you will be getting minus V sat, and during the negative half cycle, you will be getting plus V sat. Or that is just inverted version of this one. This is the inverted version of this one. So that is the inverting zero crossing detector, in which the input is given to the inverting terminal, and the reference point, that is it's grounded. You are comparing the magnitude of this voltage with respect to the ground voltage, and during the positive half cycle you will be getting minus Vsat, and during the positive negative half cycle you are getting plus Vsat. Anyway, in this case also the transition from plus Vsat to minus Vsat, that is taking place at this zero crossing point. Again from plus Vsat to minus Vsat, that is taking place again that zero crossing point, so that we can detect the point at which the input is crossing the 0 points. That is why again that is called a zero crossing detector. Now for the zero crossing detector there are two types. One we call it as non-inverting zero crossing detector, in which you are connecting the input at the non-inverting terminal, second terminal is grounded. And in inverting zero crossing detector you are applying the input to the inverting terminal and the non-inverting terminal is grounded. Then output will be either plus Vsat or minus Vsat depending upon the magnitude. If it is positive half, it will be plus Vsat, negative half, it will be minus Vsat. In this case, during the positive half cycle, it is minus Vsat. In negative half cycle, it will be plus Vsat. Therefore, this is a zero crossing detector which detects the instant at which zero is crossed by the input waveform.